Hello, and welcome to your 1412 mini lecture on acids, bases, and pH. We will be covering acid-base equilibrium for the next few lectures. Therefore, a foundation of understanding acids and bases will serve you well and help to ensure your success on this unit. There are three different definitions of acids and bases. The first two are covered in 1411, and we will review them today. The third one is covered in this lecture. The first definition is called the Arrhenius definition of acids and bases. It is keyed in on H plus and OH minus. An acid produces H plus in water. A base produces OH minus in water. An Arrhenius acid usually has H in it. An Arrhenius base does not have to have OH minus in it. The second definition of acids and bases is called the Bronsted-Lowry definition. It is keyed in on the proton. A neutral hydrogen is a proton with one electron. When hydrogen loses its electron, it becomes just a proton, otherwise known as H+. A Bronsted-Lowry acid donates a proton, which came from the H in the acid, and a Bronsted-Lowry base accepts that proton. Within the Bronsted-Lowry definition, there are several vocabulary terms you will need to know. When a base accepts a proton, it becomes the conjugate acid. When an acid donates a proton, it becomes the conjugate base. Notice that reversing the reaction also gives an acid-base reaction, only now the conjugates become the reactants. The Arrhenius definition of acids and bases was only applicable to those bases which contained or produced hydroxide. Therefore, the Bronsted-Lowry definition was developed to be more inclusive of all the different types of acid-base reactions which exist. However, even the Bronsted-Lowry definition does not include all acid-base reactions. So, the Lewis and base definition was developed as the most comprehensive and general definition of acids and bases. A Lewis acid accepts an electron pair to make a coordinate covalent bond. A Lewis base donates an electron pair to form a coordinate covalent bond. Here we see the proton, which came off of the water, accepting a pair of electrons on the oxide ion to form a bond. And the oxide is donating that pair of electrons in the bond. Water undergoes an acid-base reaction with itself to form the hydronium ion and hydroxide. If one writes the equilibrium expression for this equilibrium, one gets Kw, the equilibrium constant for water. In a neutral solution, the moles of acid are equal to the moles of base, and in this equilibrium, that means the hydronium ion concentration equals the hydroxide ion concentration equals 1 times 10 to the negative 7. This means that Kw is equal to 1 times 10 to the negative 14th. In fact, no matter what the pH of a solution, Kw will always equal 1 times 10 to the negative 14. pH is defined as the negative log, P means negative log, of the hydronium ion concentration. When water is pure, the pH is equal to 7. Solutions with pH lower than 7 are acidic. Solutions with pH higher than 7 are basic. When you add pH and pOH for a solution, they always add up to 14. This comes directly from the fact that in any solution, Kw equals the hydronium concentration times the hydroxide concentration equals 1 times 10 to the negative 14. If one knows the pH of a solution, they can also easily calculate the pOH of that same solution. This has been your 1412 mini lecture on acid-base definitions. Please go to your homework website and finish any related assignments at this time. If you run into trouble, please do not hesitate to ask for help. Help is always available.